Hey there, sky watchers and science enthusiasts. Have you ever wondered what causes that big boom in the sky during a storm? You know, that loud rumble that follows a flash of lightning. Well, you're in for a treat because today we're diving into the fascinating world of thunder. Stick around as we unravel the mystery behind this powerful natural phenomenon. Thunder isn't just a sound effect that comes with lightning. It's actually a direct result of lightning itself. But how does this work? Let's break it down step by step. When lightning strikes, it creates a narrow channel of incredibly hot air. We're talking about temperatures that can reach up to 50,000 degrees Fahrenheit. That's about 5 times hotter than the surface of the sun. Imagine that. This superheated air expands rapidly, pushing outward with great force. As it expands, it creates a shockwave that travels through the air. This shockwave is what we hear as thunder. Now, you might be wondering why we see lightning before we hear thunder. Well, it's all about the speed of light versus the speed of sound. Light travels much faster than sound, so we see the lightning flash almost instantly. Sound, on the other hand, takes its sweet time to reach our ears. Here's a fun fact. You can use this time difference to estimate how far away the lightning is. Count the seconds between seeing the flash and hearing the thunder. For every 5 seconds, the lightning is about 1 mile away. But why does thunder sound different sometimes? Sometimes it's a sharp crack, other times it's a low rumble. The answer lies in how close you are to the lightning and the shape of the lightning bolt. If you're close to the lightning strike, you'll hear a sharp, loud crack. This is because you're hearing the shock wave from the part of the lightning bolt nearest to you. If you're farther away, you'll hear a longer, rolling rumble. This happens because you're hearing thunder from different parts of the lightning bolt. The sound from the bottom of the bolt reaches you first, followed by sound from higher up. The shape of the lightning bolt also plays a role. A straight bolt creates a single, sharp crack. A zigzag bolt produces a more complex series of sounds. Now, let's talk about something called heat lightning. Have you ever seen flashes of light during a warm summer night but heard no thunder? This isn't actually a different type of lightning. It's just regular lightning that's too far away for you to hear the thunder. Remember, light travels much farther than sound. So you can see the flash from many miles away, even when the thunder has faded out. Here's another interesting tidbit. Thunder can't be heard from more than about 10 miles away. The sound waves dissipate and become too weak to hear beyond this distance. Let's move on to some thunder myths and facts. You might have heard that thunder never strikes twice in the same place. This is actually not true. Lightning can and does strike the same place multiple times. Another common belief is that thunder and lightning happen at the same time. As we learned earlier, this isn't the case. Lightning always comes first, followed by thunder. Now, you might be wondering if there's thunder on other planets. The answer is yes, but it's not quite the same as Earth's thunder. On Jupiter, for example, there are lightning storms, but the atmosphere is different. This means the thunder would sound different if we could hear it. Let's talk about thunderstorms for a moment. These storms form when warm, moist air rises rapidly in the atmosphere. As it rises, it cools and condenses, forming clouds. The movement of water and ice particles inside these clouds creates electrical charges. When the charges build up enough, we get lightning and, consequently, thunder. Thunderstorms are more common in some parts of the world than others. Areas near the equator tend to have more thunderstorms. This is because there's more heat and moisture in these regions. Did you know that thunder can actually be dangerous? While it's the lightning that poses the direct threat, thunder can be extremely loud. At close range, it can be as loud as 120 decibels. That's about as loud as standing next to a jet engine. This intense sound can cause hearing damage if you're too close. So, what should you do during a thunderstorm? The best advice is to stay indoors and away from windows. If you're outdoors, avoid tall objects and open areas. And remember, if you can hear thunder, you're close enough to be struck by lightning. Before we wrap up, let's recap what we've learned. Thunder is caused by the rapid heating and expansion of air around a lightning bolt. We see lightning before we hear thunder because light travels faster than sound. The distance and shape of the lightning bolt affect how thunder sounds. Thunder is just one part of the complex and fascinating phenomenon of thunderstorms. And there you have it, folks. The mystery of thunder, unraveled right before your eyes and ears. Next time you hear that rumble in the sky, you'll know exactly what's going on.